So, a typical size of capacitor stores about 2 joules of energy. Just for comparison, a AA battery has about 15,000 joules of stored energy, which makes 2 joules sound pretty small. How could we increase it? We could have a higher voltage across it. We know that the stored energy is half CV squared. But that might not be convenient. For most uses, we know how much voltage we want. So we need to be able to increase the value of C. You remember the equations we looked at for finding the capacitance of different shapes of capacitors. In all of them, increasing the dimensions of the capacitor will increase the capacitance. However, we might have applications where we need a small-sized capacitor. So what else can we do? The answer is to use a dielectric material in between the plates. All the capacitors we've looked at so far have assumed air between the plates. Of course, we need to have an insulator between them because anything conductive would just let current transfer from one plate to the other and it could never charge up. What we need is a dielectric material. That is an insulator that has atoms that can be polarized. So they have one end positive and one negative, and when you put them in an electric field, they will line up. These polarized atoms, called dipoles, will line up so that their positive end is near the negative plate and vice versa. Since they are all aligned, they will create an electric field of their own in the opposite direction to the field of the capacitor. This will reduce the net field in between the plates. Now to the obvious question. Why is that a good thing? Well, remember that capacitance equals Q over V. If we have a fixed charge on the plates and put a dielectric in, since V equals E times D, if the electric field is lower, then the voltage will be lower. And since voltage is on the bottom of that equation, then the capacitance increases. Or, if the voltage is fixed because that's the supply voltage, you will need a higher charge Q on the plates to make the same electric field. Either way, C is larger. And the factor by which it increases is called the dielectric constant kappa. It's the ratio of the capacitance to what it would be with free space, in other words vacuum, between the plates.